Okay? So, bullet's acceleration and delta T are given, and implicitly the bullet's going to be fired out of a barrel, so your initial velocity is going to be 0. And your T equals 0 is going to occur when you pull the trigger, or when the powder explodes, whatever. Okay? So, you got that. What definition's involved? That's the only definition that's involved in the first step. You can't determine anything else until you figure out the velocity. Okay? Delta V and VF follow from the definition of acceleration. Okay? Now, an important point here is you're assuming a uniform acceleration. Did I say?
They don't say it explicitly in the problem. They say it's average acceleration, but this is in the section of motion with accelerated or constant acceleration.
Okay, so they don't say that the acceleration is constant, they just say the average acceleration. You don't know what the acceleration is in the first microsecond and the last microsecond, much less the microseconds in between. And again, we get a little sloppy, in my opinion, with the statement of the problem. Okay? They should say at the end, assume uniform, assume this is a uniform. This acceleration ain't uniform, but pretend it is. Because that's the only way you're going to solve the problem. You don't know any details of the motion, so you make that assumption. Now, a more reasonable assumption might be an acceleration that changes linearly, although it wouldn't be linear. But then you'd have to use the calculus in a way that you could, but we're not going to confuse it right now. Okay? So you're going to say, okay, so now I would recommend doing a V versus T graph, and it's going to look like this. Okay? Assuming uniform acceleration, your V versus T graph is going to look like this for the given delta T, which will go from 0 out to whatever this is, right? Okay? And you know what this is, and you know what this is. Well, then, and we can justify this, we're not going to take the time to. Because of linearity, the average velocity is just the average of initial and final. Okay? And I want to get in the habit of using V sub I. Okay? And the definition of velocity applies. Now, your book also gives you equations of uniformly accelerated motion. Using the equations, you know V naught, you know the acceleration if you assume it's uniform, which you have to do. Okay? And you know the time interval. That's 3 quantities. We can determine the others from that just using the formulas, not understanding anything about the definitions. So you should be able to do it both ways, but you know, with the equations, it's very simple.
Couldn't you also just multiply the average acceleration and the time interval it gives you to just achieve the final velocity?
Well, that's what you do. That's what the definition of.
That's what I was saying about units.
The definition tells you that delta V equals the average acceleration times delta T. It's just what it said to do. But that's a connection to the definition. You want to connect it to the definition. I'm going to assign you several problems out of this for next week. Some of them are simple, like the ones we've looked at, and some of them are a little more complicated.
So hold on to this.
Yeah, hold on to that.
And